Hello everyone. Very good morning. Hello, hello, hello. Huh. Hello everyone. Tell me whether audio video is clear. Hello. Guys, tell me please. Okay, let's start now. So before the break, we talked about that is a two very important parameter MR and omega R for the system. And now let's we talk about we have to talk about this one. So frequency response of second order system. Okay. So we have talked about this all. Okay. Yes. So we have talked about this one. And now let's talk about a very interesting parameters, which is a bandwidth of second order system. So let's talk about bandwidth of second order system. So let's do it. See here we talk say we say that mj omega is this one, m omega is this one. M omega we say that m omega is k divided by root of 1 minus of u square to the power u square plus 4 zeta square u square. And we say that we have a plots, family of plot. Is it clear? So for example, if you want to talk about the bandwidth, then see here the certain value that it will take is 1. Neglecting any peak, this is the response I have. This is the response I have. So what is the value that it will take at omega is equal to 0? It is the maximum value. Omega is equal to 0 means u is equal to 0. U is equal to 0 is the maximum value maximum value is 1. So when this u becomes 1 by root 2 of its maximum, that's the bandwidth. What is the bandwidth? Come on. The bandwidth is when it takes the maximum value here. When it takes the maximum value here, and it's the 1 by root 2 of its maximum, means that I want that u where it will take the maximum value. So 1 by root 2 equal to k divided by root of 1 minus u square whole square plus 4 zeta square u square. Let me call this as UC. UC is the bandwidth. So this means that 1 minus UC whole square plus 4 zeta square UC square is equal to 2 when you compare. So let's do it. So when you solve, then is the a square 1 plus b square u4 minus 2ab minus 2 u square c plus 4 zeta square u c square is equal to 2. So let us find out the UC. Okay, UC, I'm calling it to be like in this way, UC to the power 4, okay, plus I'm taking UC square as a common. So let's take a minus UC square as a common. So it is 2 minus, let's take a 2 UC square common. So you have 1 minus 2 zeta square and it is minus of 1 equal to 0. Are yes or no? So I am finding that u where the gain is maximum of 1 by root 2, means that frequency. This is in terms of u. So I am finding that u where the is the 1 by root 2 of its maximum. So let's find out. Let's take UC square as x, so that it is equal to x square minus 2x 1 minus 2 zeta square minus of 1. Let us substitute for x. So x is minus b, means 2 1 minus of 2 zeta square plus, I'm not taking negative because after all, what is u? U is omega by omega n. Don't forget this. And frequency never be negative. So I'm not taking a negative case. I'm always taking a positive case. So root of b square means a, this whole square, 1 minus of 2 zeta square whole square b square minus 4 ac. A is plus 4. You will say like that. So minus b, don't forget this, b is whole, no? So it is 4. B square means 4 and divided by 2. This is u, this is x square, this is x or not? Arey oh bhai, this is x. So let's remove this one. So this is equal to how much? 2 can be cancelled out. This is x. 2 can be cancelled out. So what it is nothing but my root of x is equal to 1 minus of 2 zeta square plus, I am taking 4 as a common, so it is root of a square 1 plus b square plus 4 zeta 4 minus 4 zeta square plus 4. Check it, sir. Is this the case? Is this the case or not? Any mistake? Come on. I have taken 2, 2, 2 common, so I left with 1 minus 2 zeta square. I don't think I have made a mistake. Any mistake? See, this is x, but what is the u? U is root x. This means that UC is root of how much? Root of 1 minus 2 zeta square plus 4 plus 1 5. 5 plus 4 zeta 4 minus 4 zeta square. Check it. Check the value of b. What's the problem in b? It's a 1 minus 2 zeta square. So no need of under root there. Acha, see. That's what I am saying. I am making a mistake. So this should be. So there is a no, and there is a no. So it is 1 minus of 2 zeta square. Can we say like that? Now clear? अरे बोलो भाई. Now clear? Tell me. So what is omega c? If it is a UC, then it is a omega c. So omega c is finally, check it, omega c is omega n, a big root 1 minus 2 zeta square plus 4 zeta 4 minus 4 zeta square plus 5. Let me check that whether we evaluated correct or not. So everything is correct except this value. This value is coming out to be 2. Where we made a mistake. Yes, this should be minus, na? Which this should be minus or plus? B square minus 4AC. 4A is this one. It should be plus only. So this should be, when you take a 4, Common, this should be 1 now. One printing mistake. See here, this is 4 and I am taking 4 as the common. So what you left with? Yes. What you left with? I left with 1 now. So this should be 1. So this should be 1 plus 1, 2. Two now. So this should be not 5, this should be 2. So this is the bandwidth. Okay. What is the bandwidth when zeta is equal to 0? When zeta is equal to 0, then the peak is like this. See, don't you think? It starts from 1, it will go like that, and then come back. So what is the bandwidth here? This is the bandwidth, omega c. So tell me the bandwidth when zeta is equal to 0. It is this 0, this 0, this 0. 1 plus root 2. Omega c is omega n root of 1 plus 1.414. Are yes or no? Yes or no? Because everything is 0, no? This is 0, this is 0, this is 0. Zeta is 0, I am taking. So you left with root 2. Root 2 is 1.414. 1 is already there. So 1 plus 1.414, which is 3.414, and root of that is what? Root of that is, come on, where's calculator? Root of 3.414 is how much? 1.55. Omega c is 1.55 of omega n. Check it. Come on. Omega c is 1.55 of omega n. अरे बोलो भाई. Yes or no? अरे बोल दो यार. ओ भैया. What is the bandwidth when zeta is 1? When zeta is 1, what is the bandwidth? It is less than zeta 0 or not? Check it. When zeta is 1, 4 minus 4 becomes 0, and it is a 1 minus root 2 plus root 2. In that case, the bandwidth comes out to be negative, imaginary. Check it. No. It is a 4. Zeta is equal to 1. 4 minus 4 is 0. And this is root 2. So it is 1 minus 2 plus root 2 of root. So 3.414, 2.414, it is root of 4.414. Real. 0.643. So don't you think that when you put it is zeta is equal to 0, it is zeta is equal to 0. And when you put zeta is equal to 1, so the curve starts from here. And this time the bandwidth is this. Which is 0.644. How much? 0.643. This is the bandwidth. So what I want to say is that as you increase the values of zeta from 0 to 1, the bandwidth will shift towards left, means bandwidth is decreasing. Are bolo bhai? Bandwidth will decrease, yes or no? So for zeta is equal to 0, the bandwidth is maximum 1.5 of 55 of omega n. But as you decrease with this one, the bandwidth will decrease. So what I want to say is that we can make a plot of bandwidth versus omega. So this is the maximum bandwidth, and it will decrease. This is the bandwidth versus omega. So bandwidth versus zeta, yes. So bandwidth versus zeta, it will decrease like that. So that is the curve that is the relationship for bandwidth. Don't forget this. And itself, this is one of the most important relationship we have. This is zeta. Okay. Yes. Now let's talk about two things. So we have a plot. Now let's summarize everything. From magnitude plot, what we have covered till now is this. It starts from this. Either this will be the case, or this will be the case, or you will say that and so on. This will be the case. So we have evaluated these values as omega r, which is omega n root over 1 minus of 2 zeta square for any zeta. So this is zeta equal to, let's say 1. This is zeta equal to 0. Let's say zeta equal to 0.1 and so on and so forth. This is zeta equal to 0.707. We say that this is, we call it as a MR. And MR was, if you remember, this is K divided by 2 zeta 1 minus of zeta square. Next thing is that we have evaluated the bandwidth for this comes out to be a bandwidth, and for any, this is the bandwidth for this section. So this is the bandwidth for this section. Let's call it as zeta equal to 1. And you are saying that this is omega c when zeta equal to 0, and this is the omega c when zeta is equal to 1. So this is the values of zeta, this is the omega. Just we call it as a omega, and so on and so forth, and this value will go on decreasing like this. Okay, so that's the enough magnitude plot we have talked about. We have talked about omega r, we have talked about this value is when k is omega equal to 0. This is a very interesting value, very interesting value. So every plot will start from here. So that is omega equal to 0, and so on. It is increasing omega. So this plot will go on like that. Now that's all about the omega plot that we have covered. But let's talk about the phase plot. I want a phase plot also. So phase, we have said that this is the phase, this one, and that is phi omega. We say that phase plot so phi omega is what? Minus tan inverse of 2 zeta u, which is, let me write in this way, omega by omega n divided by 1 minus u square, means omega by omega n whole square. And let us plot the phase here. Let's do it. What will happen when you put omega to be equal to 0? When you put omega to be equal to 0, the phi of omega is equal to 0, because this term is 0, this term is 1, this term is 0. So tan inverse of 0 is 0. What will happen when omega is equal to omega 1? When you put omega is equal to omega n, this term becomes a 1, and 1 minus 1 becomes a 0. You will get tan inverse of infinity, and hence we have a phi omega which is equal to minus 90 degree. Don't forget that I have a minus sign here. Question is that what is when omega equal to infinity? What is omega equal to infinity? So omega equal to infinity, so don't you think that this term is now very high? So we will say that we have, okay, let me write this way. So we have minus of tan inverse of 2 zeta x divided by 1 minus of x square. And since, since x is, hello everyone, x is equal to infinity, ranging towards infinity, so that means 1 is very small as compared to x. So we can write this as tan inverse of 2 zeta divided by minus x. Don't you think? Oh bhaiya, don't you think? So don't you think that I will get minus x plus iy case, minus a plus jb case? Here See, imaginary part is negative, real part is negative, and imaginary part is positive. Oh, bhaiya. Are bolo. So we have just covered the root locus, and many times we have did this. So it is the case of second quadrant or not? Oh, bhaiya. It is the case of second quadrant or not? It is the case of second quadrant. So when you put x tending towards infinity, very large value. So this is nothing but my 0, but don't forget that it's a 180 degree. So 180 degree minus 0. Are bolo bhai. But don't forget the minus sign here. So this means that when x is tending towards infinitive, the angle is, because of this minus sign outside, the angle is minus 180 degree. When x is tending towards the infinitive, this term is very, very large. So we left with minus x square, xx cancel, and this is now the case. Forget about this minus sign. Say, this is the case of minus a plus I by minus a plus jb, and it is a case of second quadrant. So second quadrant means that 180 degree plus theta. So theta is tan inverse of 0, because infinitive when you put, it becomes 0. Tan inverse of 0 is 0. So you will get a net angle of 180 degree. But outside there is a minus sign. So this means that you will get a net angle of minus 180 degree. Okay, fine. So this means that, sir, I have an angle starting from 0, as omega infinity, as omega infinitive, the angle will become a minus 180 degree, and it will touch minus 90 degree. This is a minus 90 degree, this is minus 180 degree, this is 0 degree, this is phi omega versus omega. It will touch minus 180 degree, mind it, at omega n. Yes or no? This kind of phase I will get or not? Oh bhaiya. This kind of phase I will get or not from second order response? So it is a 0 degree decreasing phase. I will get maximum phase of minus 180 degree when omega becomes an infinity. अरे बोल दो यार. Yes or no? So maximum phase of minus 180 degree when omega equal to infinity. Everyone must tell. When omega becomes an infinity, then this will have minus 180 degree. And when omega is equal to omega n, then this is nothing but my having a this kind of phase. Yes. Okay. So that is enough about nothing but my magnitude, phase and phase plot. So we have talked about the magnitude, we have talked about the phase. What is the m omega? Let me write this m omega. What we have plotted? M omega is 1 divided by, that is a 1 minus of omega by omega n whole square plus 2 zeta omega by omega 1. So we have plotted this basically with respect to omega for different zeta, and different omega is equal to omega. Okay, so next topic is that correlation between, see, exact plot I have talked about this. This is zeta, okay, this is zeta. When zeta is greater than 1 by root 2, we have this one. When zeta is this. Achha. Let's talk about correlation between time domain specification, and frequency domain specification. So what is time domain specification we have covered? We have covered for second order response for second order step response Sir, we make the plot like this, if you remember. And I say that my plot is this, and that was an overshoot. I'm calling it as a MP. That was a settling time. And then that was a rise time, if you remember. And that was a peak time. I'm not interested in delay time. So time domain parameter says that my MP was e to power minus of zeta pi divided by root of 1 minus of zeta square. My peak time was n pi by omega d. Let's take for first case pi by omega d. And my rise time was pi minus cos inverse zeta by omega d. These are the three parameters I'm interested in. And everything I evaluated for the case that I have a two pole in which this quantity was minus zeta omega n, this quantity was j omega d, so that I have a two pole, one is here, one is here, and the distance from here to here and here to here is basically the second order pole, and this is the angle. I am calling this angle as a theta. So this distance I am calling it to be the omega n. And what is the omega d basically? Omega d comes out to be omega n root of 1 minus zeta square. This is having a maximum value of 1. And for the same system, I have evaluated the frequency response in this way. So let us correlate everything. What I want to say is that suppose someone talk about, let's say, maximum overshoot and MP. So MP is this e to power minus of zeta pi upon root of 1 minus of zeta square, and as zeta increases, MP decreases. We solve many problems based on that. So overshoot will decrease as zeta decreases, and see, look at that. Just now we have covered that MR is equal to 1 over 2 zeta root of 1 minus of zeta square. Here also, if you increase the, let's say, if you increase zeta, then MR is decreasing. So as zeta increases, MR also decreases. This is the first point. So the peak overshoot or peak resonance both will decrease as zeta increases. So for zeta is equal to 0, you have some MP. For some MP, if you put zeta is equal to 0 here, this becomes e to the power, listen carefully, If zeta is equal to 0, if you put, then this term becomes 1, MP becomes 1, the maximum overshoot 100%. But as you increase the values of zeta, and let's say zeta is 1, don't say that zeta will increase to infinity. Zeta, what is the range of zeta? Don't forget this. What is the range of zeta? Maximum zeta is C. Zeta is equal to 0 is undamped, and zeta is equal to 1 is underdamped. Between undamped and underdamped, the response you have to evaluate. Don't say that zeta becomes infinitive. Overdamped case we never take. We always take 3 cases: critically damped, overdamped, undamped, and underdamped. 0 to 1. So for this case, so if you put zeta is equal to 0, then you will get 1. And when you put zeta is equal to 1, 1 minus 1 becomes a 0. And this becomes nothing but my 1. This becomes an infinity in that case. Under root of infinity is the infinity only. E to the power minus the infinity becomes a 0. So as you increase the values of zeta, this becomes 0. Here also, if you increase the values of zeta, this will decrease. Let's talk about this one. Let's talk about the relationship between omega r and omega d. So omega r and omega d. Now you say that my omega d comes out to be like omega n root of 1 minus of 2 zeta square. And my omega r is this. This is omega r. And my omega d comes out to be omega n root of 1 minus of zeta square. So when you take the ratio omega r by omega d, this comes out to be 1 minus 2 zeta square upon 1 plus zeta square. 1 minus zeta square. So that's one of the most important relationship we have. So omega r over omega d, resonant frequency over damped frequency, is 1 minus 2 zeta square over 1 minus of zeta square. So for example, if I put zeta equal to, mind it that everything is valid here now for what? Everything valid here is, don't forget that zeta is from 1 by root 2. Zeta is from 1 by root 2, because then only this term becomes a what? Real term. Otherwise minus sign will come into the picture. So for example, if you put zeta is equal to 0.5, example, if you put zeta is equal to 0.5, then omega r is omega d root of 1 minus of 1 divided by 1 minus of 0.5 whole square, 0.25. And this gives me answer as, no, sorry, not 1. So zeta is 0.5 is 0.25. 0.25 into 2 is 0.5. 0.5 it is. 0.5 upon 0.25, I think 2 omega d, check it. Root 2 omega d, I think so. Check it. अरे राजा कैसे कर रहे हो साईं चंदर? Look at the relationship. ओ भैया, ओ साईं चंदर, हाँ, tell me, for zeta is equal to 0.5, what's the value? See, 0.5 whole square is 0.25, 0.25 into 2 is 0.5, 1 minus 0.5 is 0.5. Here 1 minus 0.25, no, it's not root 2. What's the value? Tell me. 0.5 by 0.75. Means 1 by 7.5, 10 by 7.5, 2 by 15. Check it. Omega d. 2 by 15, root 2 by 15 omega d. Check it. When you put zeta is equal to 0.5. अरे बोलो भाई. Everyone must comment here. Yes or no? 0.816. 0.816. Okay. So now this is the case. Acha. Now omega r and settling time. And omega r and peak time. Then bandwidth and settling time. Establish the relationship. I am giving you 2 minutes. Establish the relationship between omega r and ts. Establish the relationship between omega r and tp. Establish the relationship between bandwidth and settling time. Settling time. What is the bandwidth formula? Bandwidth formula is omega c is equal to omega n root of 1 minus 2 zeta square root of 4 zeta 4 plus 4 zeta 4 minus, what is bandwidth? Minus 4 zeta square plus 2. Establish the relationship, make it fast. Coming in 2 minutes. Yes, bhai. What's the first relationship? See here, omega r. Omega r is omega d. Sorry, omega c root of 1 minus of 2 zeta square. And now Ts is 4 by zeta omega n. This means that omega r can be also written as instead of omega n we put 4 by zeta ts root of 1 minus of 2 zeta square. Can we say like that? Hello? Can we say like that, sir? Can we say like that? Yes or no? 4 by ts root of 1 minus of 2 zeta square by zeta. अरे बोल दो यार. Yes or no? And what is the omega r versus tp? You know that tp is pi by omega d. Omega d is pi by omega n. Omega n root of 1 minus of 2 zeta square. 1 minus of zeta square. So instead of omega n, what is the omega r? Omega n it is, no? So this should be how much? It is nothing but my omega r, and this is 1 minus 2 zeta square. So pi into 1 minus of 2 zeta square divided by omega r into is what my TP is. Check it. Is it TP in terms of omega r? अरे बोलो भाई. अरे बोल दो. TP in terms of omega r can be written like this or not? TP in terms of omega r for any fixed zeta. Array, everyone must comment here. Where are you, all of you? Shall I stop class? Shall I stop the class? Come on, everyone. Stop the class. Shall I stop the class? This is that, yes or? That is a bad effect. That is the drawback of. हाँ Thanuja, stop the class or not? Stop the class or not, Thanuja and Ushashi? This is TP. Now, omega n, you can write it in terms of settling time. So settling time is 4 by zeta omega n. 4 by zeta omega n. And instead of omega n, we will write 4 by zeta ts. So bandwidth omega c can be written as omega n 4 by zeta ts times 1 minus of 2 zeta square plus root of 4 zeta 4 minus 4 zeta square plus 2. Again, a very important formula. So no need to remember, sir. See, you have enough formula to remember. Don't remember these kind of things also. That what is the omega r in terms of settling time. We know everything. See, we know MP, TP, TR, and TS. And TS, which is 4 by zeta omega n. And we know omega D, omega R, MR, and bandwidth in terms of zeta. So you just have to remember all these formula easily we remember, yes or no? So this formula is just, you have to new formula you got, and whatever the relationship he said, you just have to manipulate it. Otherwise, how many formula you remember? Can you imagine? We cannot remember omega R with omega D. These kind of formula, it's very confusing formulas they are. See, in one of the PSUs, not PSUs, earlier in before I think 2018, DRDO was also taking their own exam. Once DRDO, I don't know, from nowhere, asked a relationship between zeta and phase margin. What is phase margin? We will see it in polar plot. But let me give you some concept about phase margin. Phase margin is that phase. Phase margin is that phase which you evaluate at gain crossover frequency. What is the gain crossover frequency? See here. First of all, we will evaluate the gain crossover frequency. Gain crossover frequency is that frequency where the magnitude m omega becomes a 1. At this omega g, whatever with the phi g we have, we say that it is a phase at omega g or gain crossover frequency. Now, what is the phase margin? What is phase margin actually? We will see this phase margin in very detail. Gain margin, phase margin is my topic separately. So I will tell you what is the internal meaning of phase margin, but just for sake of formulae, can you derive the phase margin is 180 degree plus phi of omega g. That is the phi of omega g. Phi g is the phase at omega g. Add 180 degree, you will get this one. Can you derive the relationship zeta and phase margin? I think in the 2015 itself. 2015 they asked an objective type question that the zeta is related with the phase margin of what? See, you know that what is the m omega? M omega is what? 1 over root of 1 minus u square whole square plus 4 zeta square u square. Where what is u? U is omega by omega n. Now I want omega g. So ug is omega g by omega n. Now at u is equal to ug, the gain is equal to 1. At gain crossover frequency, the magnitude is equal to 1. What is the meaning of that? We will see this, sir. Guys, don't worry about the meaning. We will see the meaning in this week itself. Don't worry about this. But let us derive this one. Omega g is equal to 1. So this means that 1 minus u square whole square ug whole square plus 4 zeta square u square has to be equal to 1. Let's solve for ug. When you solve, just this one, it's a 1 plus ug to the power 4 minus 2 ug square plus 4 zeta square ug square, okay, has to be equal to 1. And I want a ug so that we can find out the gain crossover frequency here. Okay, now what I'm doing is that 1 cancel. First of all, I'm taking this ug square as a minus ug square as a common, so we left with ug to the power 4 minus ug square I'm taking as a common, ug square as a taking as a common, so what you left with is a 2 minus 4 zeta square has to be equal to 0. So this means that what you get is ug square is equal to 2 minus 4 zeta square, and hence ug is root of 2 minus 4 zeta square. What is ug? Ug is omega g, gain crossover frequency, by omega n. So gain crossover frequency in this way I will get omega n 2 minus 4 zeta square. Now you know the phase relationship. What is the phase relationship, by the way? Phi is equal to how much? Tan inverse of minus tan inverse of 2 zeta u. This is the phase relationship. We have evaluated on the phase now. This 2 zeta u divided by root of 1 minus of 1 minus of u square. Check it. Is it? Yes. So let's do it. U is this one. U is this one. So phi is minus of tan inverse of 2 zeta root of 2 minus 4 zeta square divided by 1 minus u square, directly put. Will it make a difference? Instead of u, let me write this in this way, that phi is equal to minus tan inverse of 2 zeta u omega g by omega n upon 1 minus omega g by omega n whole square. Check it. So it will not make a difference. It is a minus tan inverse of 2 zeta. Directly I am writing this omega g is this one. So directly you will get 2 minus of 4 zeta square divided by 1 minus of omega g square, omega g by omega n. So it is, yes, 2 minus of plus of 4 zeta square. Okay. So this will be equal to minus tan inverse of how much? 2 zeta root of 2 minus 4 zeta square divided by, I am taking minus of 1 minus 4 zeta square. This is phi omega g. Sir, don't you think that again y by minus x I will get? So what is the net phase? It's the net phase is phi omega g can also be written as minus of 180 degree divided by this phase. 180 degree minus tan inverse of 2 zeta root of 1 minus of zeta square divided by 1 minus of 4 zeta square. Now 4 zeta square minus 1. Yes, 1 minus of 4 zeta square directly. This is phi omega g. But what is phase margin? Phase margin is PM phi, phase margin is 180 degree plus that phi omega g. So it is 180 degree minus 180 degree and minus minus plus tan inverse of 2 zeta root of 1 minus of zeta square divided by 1 minus 4 zeta square. So directly this cancel, and hence phase margin is tan inverse of 2 zeta root of 1 minus of zeta square divided by 1 minus of 4 zeta square. Of course, zeta has to be less than 1 by root 2. Means this term anyhow will be positive, because negative case I already have taken. Means basically 1 minus 4 zeta square has to be greater than 0. Means 4 zeta square has to be less than 1, or zeta square has to be less than 1 by 4, or zeta has to be less than 1 by 2. Means this is the case, not root 2, 1 by 2. Because in that case this would be positive. I want this positive, because negative case I already have taken 180 degree of that. If zeta is less than 0.5, then this term also positive, this term also positive. Array, hello everyone, yes or no? This is phase margin. What is phase margin? We will see in this week itself. What do you mean by phase margin? We have a relationship with respect to phase margin and zeta, and phase margin has to be less than, zeta has to be less than 0.2, because now don't make this negative, otherwise 180 degree again will come. Phase margin is a net angle which makes the system unstable. What it is, we will see this. Hello guys, this is the phase margin. Sir, in gate they will never ask you, but once they ask in DRDO, that's why I am telling you. Is this point is clear to you? Oh bhaiya, relationship between zeta and phase margin. But zeta has to be cautious, zeta has to be less than 0.5. अरे बोल दो यार, बोल दो please. Is it clear? Huh. Yes. So we are in position to handle the problems. Let's start the problems. Look at the first problem. First order system we have evaluated already. So everything will be deleted from second order. Frequency response of second order we have to take. Yes. Solve the problems. Make it fast. Make it fast. The first question. In this system shown below, the steady state response will exert a resonant peak at a frequency of. Basically, he will talk about resonant frequency. Make it fast. At the frequency of. From tomorrow onwards, we will talk about the polar plot. Okay. What's the answer? What's the answer? Come on. अरे बोल दो यार. Come on. What is the answer? Resonant frequency. Hmm. Hmm. बोलो भाई कितना आया? अरे एनीवन इज देयर. √2. √2. अरे बोलो भाई बाकी. What is CLTF? Is 20 by s square plus 6s plus 70. So omega n is √20. 2 zeta omega n is 6. So 2 √20 is 6. Means zeta is 6 divided by 2 √20. This means the 3 by root 20. What is 3 by root 20? What is 3 by root 20? It's a 0.670. 0.670. This means that since zeta is less than 1 by root 2, which is 0.707, so resonant peaks occur. So tell me at this, what is the omega r? Omega r comes out to be omega n root of 1 minus of 2 zeta square. Omega n comes out to be root 20. So root 20 into root of 1 minus of 2 into 0.670 whole square. So it is a square into 2, 1 minus answer, root answer into 1.414. Omega r comes out to be root 2 or radian per second or 1.414. Yes, perfect. Do it. A system has 30% of overshoot and settling time of 5 seconds for unit step input. The resonant peak of system is, make it fast. Now just a formula putting questions there. From tomorrow onwards, guys, we are talking about what? We will talk about polar plot, mind it. Do it fast. Point 3 is the MP. This means that zeta is minus ln MP divided by root of pi square plus ln MP whole square. Okay. So it is a minus ln of 0.30, 30 by 100, 0.3 divided by root pi square plus ln 0.3 whole square. So how much? Point 0.35 is the zeta. Point 0.35 is the zeta. What he say? The resonant peak means MR 1 by 2 zeta root of 1 minus of zeta square. 1 by 2 into 0.35 into root of 1 minus of 0.35 whole square. One 1.52, I think so. Check it. Is it? अरे बोलो भाई. बोल दो यार. From MP we calculated MR 1.52. हाँ. The open loop and closed loop transfer function of a system respectively given by this one. The ratio of bandwidth of open loop to open loop. We can easily find out now. See here, what is the bandwidth we calculated? Bandwidth is what? Here the pole is at k divided by s tau plus 1. So where is the pole? Pole is at 1 by tau. 1 by tau, na? Pole is at minus 1 by tau. So what is the bandwidth? Closed loop to open loop. Acha. Closed loop to open loop. Acha, closed loop is this. K by s tau plus k plus 1. This means that it is the k plus 1 by tau. This is this one. This is I don't know, there's a printing mistake here somewhere. Which is open loop? If this is the open loop, is this the open loop? I think there's a printing mistake here. I don't know which is the open loop. There, here also open loop is written, here also open loop is written. If we talk about, for example, if we forget about this question, if we forget about this one, suppose if I forget about this one, then the CLTF is this, CLTF is this, and OLTF is this. So the pole location is this one, means I told you that for first order system the pole location is a bandwidth. The pole is at minus k by tau. Pole is at 1 by tau, sorry. And here the pole is at for OLTF. And the pole is at minus k plus 1 by tau. So this is the bandwidth k plus 1 by tau upon 1 by tau. This means that answer would be k plus 1 if this is not the case. Otherwise, there is a printing mistake here. Answer would be k plus 1. So you remember in the first order, what is the bandwidth? Bandwidth was just a pole. Are bandwidth was just a pole or not? Are bolo bhai. In the first order, we derived today. We derived or not? Bandwidth was just a pole. So k by, you remember na? K by s tau plus k. The pole location was a bandwidth. So the pole location is k plus 1. So in that case, B is the answer. Okay. For unity feedback control system, GS is this. The forward part transfer function, the peak resonant magnitude MR is 2. The corresponding value of gain K is. What is the MR? Is K by 2 zeta root of 1 minus of zeta square. How will you find out the zeta? For unity feedback control system, GS is this. This is the forward part transfer function. So this means that, okay, so 2 s square plus 2s plus k can be compared with s square plus 2 zeta omega n s plus omega n square. So this means that 2 zeta root k is 2. So what is zeta? Zeta is 1 by root k. Substitute here. Or yes or no? See now, 2 zeta omega n. 2 zeta omega n is 2. Omega n is root k. So zeta is 1 by root k. So when you substitute, MR, which is 2, is equal to k divided by 2 into zeta. Zeta is 1 by root k. So k root k root over 1 minus of zeta square is 1 by k. So this is equal to 4 is equal to, okay, k minus 1 k square divided by root of k minus 1. Is it the case? Is it the case or not? 4k square upon root of k minus 1. Check it. See here, from this is open loop transfer function. So closed loop will be what? S square plus 2s plus k na. Compare with your standard form, you will get omega n as root k. So from this zeta you will get 1 by root k. MR is this k divided by 2 zeta upon root of 1 minus of zeta square. In that case, yes or no? In that case, you can solve it now. See here, 4, 16 is equal to zeta to k4 divided by k minus 1. This equation is not solvable, I think so. Can you solve this equation? I don't think that you will be able to solve because no k square term is there. If you put this k as equal to 1, suppose I am taking system gain to be equal to 1. In that case, I think so, that here you will have a root k and here you will have a k. Suppose you take k as equal to 1, so it is how much? 4 is equal to k minus 1, root k, root k, root k, k divided by root of k minus 1. And 16 is equal to k square upon k minus 1. So k square plus 16k minus k square plus 16k minus 16 is equal to 0. Let's check that whether I will get the answer or not. Yes, I will get k as a 1.07 and one value is 14.92. Only k will come. Okay. So how will you verify that which one is the right answer? When you put zeta is equal to 1 by 1.07 root and inverse, then here the zeta, if you put this value, then the zeta comes out to be 1.9996. But if you put k root 14, here zeta comes out to be 0.26. Tell me which value of k is there. Which value of k you will take? Here it is 1. This k will be 1. 1 by 2 zeta root of 1 minus of zeta square. And that in that case you will follow. So tell me which value of zeta you will take. This or this? Tell me. You will take k as a 1.07 or 14.92? Are bolo. K as a 1.07 or 14.92? Here zeta coming out to be 0.96. Tell me, for this zeta, will resonant occurs? For this zeta, will resonant occur? For this zeta, will resonant occur? Are bolo yaar. Resonant occurs when zeta is less than 1 by root 2, na? Are hello. So what is the valid k? What is the valid k? Everyone must comment here. What is the valid k? Or gone? What is the valid k? Okay, you guys are not interested in question, yes or no? You guys are not interested in question. So shall I give theory only? Shall I give theory only? 14.92 is a valid k. So k value is 14.92. Okay, fine. So that completes my frequency response. Frequency response of both of first and second order system. Tomorrow we will talk about polar plot. Tomorrow we will talk about the polar plot. So with this, thank you very much guys. Thank you. Any doubt if you have, do ask the doubt. Today class you understand? Today class you understood or not? अरे बोल दो यार. हाँ, साई चंद्र रेड्डी, आर यू देयर? विजय, शरण कुमार रेड्डी, thank you very much. No response. Then it's okay. Tomorrow onwards, we will talk about polar plot. Okay. Thank you very much.